Welcome back. So have you figured out the final answer? What I found is this value here, the final V. So let's walk through the whole solution on together again. At first we need to sketch it. You don't need to draw the whole fish in your solution for sure. I just want to draw it here, then you can see what's going on. But what we need to do is what? We just need to write this one, okay? We need to show, oh, we are applying the conservations of momentum. We got the total momentum equals to a net momentum, and which is a constant. That's why before and after they just be the same. So here, when we apply the head to tail method or the parallelogram method for the vector addition, we can find that the net momentum this way. And then in order to find this way, we can say, oh, this is actually a triangle shape, right? And very especially, this is a right triangle shape with this angle to be 90. So if we know the length of this one, the length of this size, then we can find the hypotenuse, right, which is the net momentum. Why we need to find this? Because we want to find the velocity, and we know that the velocity related to the net momentum by this equation, and we know the masses already. So if we know this one, we can have this one. So then to find this one, it's just like we find the length of this one, which is mvi1, which means that the initial velocity of the first object, the fish, the big fish, and just plug in the values, then you can see that the unit of momentum should be kilogram meter per second. Just like multiply the numerical values together and just put the unit together, then we got this one. The same thing for P2I, the initial momentum of the second object, which is the little fish. So then just plug in the values again, and we got this one. And after we done the length here, we know the size already. We can find the hypotenuse, right, based on the Pythagorean theorem. Then we got this one, square equals to square plus square. And then to find this one, just let's square root both sides. So just plug in the values again that we found above. Then we have this one. This is the net momentum. Sorry. And then we know that this one is the net momentum. So then we can solve for V, right? Just have this one and then divided by this one. So then this is the final V. Okay? Yeah. So that we done with the magnitude, right? Now what about the direction? Okay, so in order to find the direction of this one, we should see what is the angle it make with the horizontal. So in order to find this angle, the tangent, how can we find the value of the tangent? Yeah, so let's just apply the right triangle again. Then we can see that the tangent of that angle should be equals to the opposite side divided by the adjacent side, right? So then it should be the pi2 over the pi1, or I will just plug in the value here. That should be like 4.5 kilogram meter per second, the unit of momentum, and then we divide it by the values of the adjacent one, which is which is a 0.625 kilometer per second. And then we can see that on a unit cancel out, right? And that makes sense because the value of the tension should be just a numerical value. And this is what I got, 4.5 divided by 8.625. Then I got about let me use another color to match with the tension colors. That should be 0.521. Okay, so then from this one we can find the angles, right? Just do the inverse functions arctan of this value, right? Or you would see that in the calculator it should be something like that. That would be like this. This is the inverse function of the tangent. Inverse function. And then I found it to be around 20.5 degree. Actually it's 27.55, so I will just round it up to be 27.6 degree. And you see, this is the angle that makes between the horizontal and the vector. So you can either say that, oh, this is the angle that the vectors make with the horizontal. But if you just say it, then it could be also this way, right? It can be like upward. So we can add that, or it should be like downward. But there's another way to describe it. So you can see that the way it moved from towards the right should be like towards the east, right? And then we can see that below that it should be the south, above it should be the north. So then we will say that, oh, this is like 27.6 degree south of east. So that should be the answer, okay? This is the angle south of the east. Okay, so that's it. Then we done. Okay, if you have any questions, please comment below, and I'm really happy to figure out together. See you in the next problem. Thank you. Good luck.